Hello students. Now for the another session of area of trapezium. I hope you all are ready. Be ready with me. In the last session of area of trapezium, we did the basic concept related to area of trapezium. That was, first of all, what is trapezium? Is a quadrilateral having exactly two sides parallel. The rest two sides are non-parallel sides. Fine. The perpendicular distance between these two parallel sides is known as height of trapezium. The perpendicular distance between these two parallel sides is known as height of trapezium. Here in this second figure you can see there is a perpendicular drop, so this will be the height. Whatever is the perpendicular is the height of the trapezium. Perpendicular from one end of one parallel side to another side. It is not anywhere you drop a perpendicular and it will work out for you. No. So then we concluded area of trapezium is equals to half into sum of parallel sides multiplied by height. What comes the area of trapezium? Sum of parallel sides multiplied by half into sum of parallel sides multiplied by height. This is what you learned last turn. You did questions based on this basic concept where you directly calculated the area of trapezium. Sometimes you calculated height. Sometimes you calculated one of the parallel sides, and in one question you calculated both the parallel sides where a relationship between the two sides was given in the form of linear equation. Am I clear? Now in today's session we are going to solve a question where we are not given height. Where we are not given height of the trapezium. And now I'll draw a figure, I'll tell you the given things, you have to tell me what needs to be done there to calculate the area of trapezium. Now students, here is a question for you related to trapezium. In the figure given below, means this figure, AB and CD are the parallel sides of a trapezium. Fine. And angle ADC is right angle, that is 90 degree. You are given AB as 15, CD as 40 as well as diagonal AC as 41. Fine. You have to calculate the area of this trapezium. First of all, you write the formula for area of trapezium, that what are the requirements of calculating area of trapezium. So let's write the requirement. Area of trapezium ABCD is equals to half into AB plus CD multiplied by height. Height is AB in this case because this is the only perpendicular distance between these two parallel sides. So that is AD. Height is AD. Now you see, look carefully and match with the figure. AB, it's okay, 15 is there. CD, that is okay, 40 is there. Fine. Now what you don't have? You don't have the measurement of AD. You don't have height. Now recall and just think, ADC is a right angle triangle, right angled at D, whose hypotenuse and base is given. So which theorem you can apply there? You can easily apply the Pythagoras theorem to calculate the length of AD. So we begin with, in right triangle ADC right angled at D according to Pythagoras theorem. Children, one thing I want to tell you, it happens sometimes in few questions you need to write statement. Don't hesitate when you are writing statements. That time you are making your question totally self-explanatory. Means you don't leave any if and but for the examiner who is checking your work. Got it? When we apply Pythagoras theorem in this question, according to Pythagoras theorem, you have AC square is equals to AD square plus CD square. You need AD square. So AD square is equals to AC square minus CD square. AC square means 41 square minus 40 square. That means 1681 minus 1600. That gives you 81. That means AD is square is equals to 81. Therefore, AD is under root 81, which is 9 centimeter. So children, you have obtained your height of trapezium as 9 centimeter. Now we have obtained AD as 9 centimeter. Come back to the area formula of area of trapezium. Area of trapezium is half into AB plus CD, that is sum of the length of parallel sides multiplied by distance between them, which you have calculated. You have both the parallel sides with you, 40 and 15. So put it in formula, half into 15 plus 40 into 9. Half into 15 plus 40 is 55 into 9. Cancel 2 and 9, you get 4.5. 55 into 4.5 is 247.5 centimeter square. This is the area of trapezium which was required from us. Now you must have understood, if you are given parallel sides, you are given along with parallel, maybe non-parallel as well, but you are not given the height. So your major task is to calculate the height of trapezium that you are going to see in your second question. Now children, I introduce with trapezium. Maybe you don't remember what I said about isosceles trapezium. A trapezium has got exactly a pair of parallel sides. That is okay. It has two non-parallel sides, and if those two non-parallel sides measure the same, then the trapezium is isosceles trapezium. What I said? If the two non-parallel sides measure the same, then the trapezium is known as isosceles trapezium. Now here is a question where you are given all four sides of a trapezium, parallels as well as non-parallels. Non-parallels are equal, so it is an isosceles trapezium. You have to calculate its area. Again you recall the formula of area of trapezium. So that is half into sum of length of parallel sides. Okay, you do have both the parallel sides. What you don't have actually, you don't have the height. So your major focus should be on calculating the height of trapezium. Just see how I continue with this. We have two methods. One is this, that you drop perpendicular from both the vertices of side CD on the base. Fine. Now it has become a rectangle. Say EF. So DEFC has become a rectangle. DEFC has become a rectangle. Whereas triangle AED as well as triangle BFC, these are two right triangles. Fine. Now again your question is very genuine. Ma'am, in right triangle we have hypotenuse, but we don't have neither perpendicular nor base. I am showing you the base. If this part is 13 and these two perpendiculars are drawn, so it's a parallelogram, so this measurement is also 13. Fine. Now out of 25 you have taken up 13. How much is left with you? 12. How much is left with you? 12. That will be equally distributed to this AE and FB. Now I hope you can see that you have hypotenuse as well as base. But you have to give this in written. Like you have AB is equals to 25 centimeter, CD is 13 centimeter. Fine. And these AD and BC, the two non-parallel sides, that is AD and BC, they are equals to 10 centimeter each. Now what we have drawn? Draw perpendiculars from D and C to AB, which meets AB at E and F respectively. Fine. So this way the entire trapezium has divided into three parts. What are the three parts? One rectangle and two right triangle. Our interest is more in getting the height of the trapezium. So we take any one of the right triangles and use Pythagoras theorem there. In right triangle, let us take, I am taking AED, it's your choice, you can take this one as well. In right triangle, AED, we have AD square is equals to DE square plus AE square. So your AD square is 10 square is equals to, your DE is unknown to you, so let it be DE square, and this is 6 square. 100 minus 36 is equals to DE square. So your DE square would be 64. DE is equals to 8 centimeter. That means the height of trapezium has come 8 centimeter. Now our purpose is fulfilled. We have no business with rectangle, triangle. We have used it because we wanted to calculate the height of trapezium. Let's move on to the area of trapezium. Area of trapezium ABCD is equals to half into AB plus CD multiplied by AD. So that is half into your 25 plus 13 multiplied by 8. That is half into 38 multiplied by 8. So you do multiplication. 4 8s are 32. 4 3s are 12 and 3. 15. 152 centimeter square is the area of this isosceles trapezium. Is the area of this isosceles trapezium.